Okay, let us try to have a video to help guide you through the use of a virtual work in the calculation of the deflection of the truss. So I am going to create the example different from what I used in the class. So let us see the truss. Looks like this, maybe. Okay. This is what we call a Warren truss. Not very engineering efficient, but it gives you a lot of space in this area that you can enjoy having conduits or pipes running through. Okay. Let's say we have a external load applied right here, whatever there may be, 15 tons, for example. And when you have this situation, you can analyze for the internal forces of each member in the truss. So let's say if this is member number 1, you can obtain N1 as the axial force of this member, and you can also obtain N2, N3, N4, N5, N6, and N7. Remember, this is the case that we analyze the truss under the actual load. So when you have the internal force of each member, the next step that you can do is to calculate the deformation of each member. So if we look at this member number 1, you can calculate the displacement of this member number 1, and it will be equal to N1 L1 divided by A1 and E1. Well, apparently nobody is going to use different materials in one truss. So from now on, I'm just going to call this E. And let's say if you use the same cross section throughout the member, throughout the truss, each member is going to have the same cross-sectional area. So we can also call this just A. Okay, and from this, you see this is going to be the displacement of, or the deformation of member 1. Okay, you can call this, I don't know, okay? And member number 2 and 3 and 4 and so, okay? So let's say we want to know the displacement of this truss. Generally, what interests engineers the most would be the mid-span vertical deflection or displacement. And if that's gonna be the case here, what we can do by using virtual work is that we can apply the unit force here at the location that we want to know the displacement, and in the direction that we want to know the displacement. Okay, actually you can apply any load, but by applying the load equal to 1 is the easiest way. So when you apply this, naturally your truss is going to respond, and you can also calculate the internal forces in the members corresponding to this unit load. So you will have N1, N2, N3, N4, N5, N6, and N7. Okay? So from here, we can come back and discuss about the concept of the virtual work now. Apparently from this case where you apply the virtual unit load, you will see that this load will produce the external virtual work equal to the unit load itself multiplied by the actual deformation at this location. Okay, I use the red one because this is going to be the actual deflection of this structure under the actual load. And remember that this is the external work. Now, the internal work is going to be equal to the internal work of all the members that constitute this truss. So let's say if you look at member number 1, the internal virtual work of member number 1 is going to be equal to the force itself, which is N1, then multiply by the displacement that N1 travels, which becomes the capital N1 L1 divided by AE. And then you can move on to the work done by member number 2. And again, the force here is N2 multiplied by the deformation or the displacement of member N2, which is equal to N2 L2 divided by AE. And then you can keep doing this until member number 7, which has N7 as the force, the virtual force, multiplied by the displacement, which is equal to N7 L7 over AE. You see, on this right side is the internal work of the system, which means you do have to summarize all the work done by all the members in the system. So on the right side, I can easily write it in terms of sigma. Sigma I equal to 1 to N I capital Ni L, Li, yes, that's right, over AI and then E. Okay, you can calculate both sides. So in the end, what you want to know, which is the deflection of this truss, can be obtained. Okay, I hope this video clip will